Hi, welcome students and colleagues to the third in the series of Introduction to PLC Control. Once again, my name is Vasan Naika and I'm from the TVET College in Pietermaritzburg. For today's lesson, we're actually going to discuss basically logic circuits and the different types of logic circuits that you would require in order to do most of your programming. All right, I'm going to discuss the latching circuit. I'm going to discuss a basic start-stop circuit. I'm going to discuss a timer and a normal interlocking circuit. Now, I've mentioned once again that I must apologize for actually going through most of the previous lectures quite fast. That's because we have a lot of time constraints. So I've now put up the utvethhelp2@gmail.com address for you once again. So if you have any questions while you are studying or while you're at home, please don't hesitate to send them to me and I will try to help you. What I'm going to do now is just go back to where we actually left off the last time. And that was understanding ladder diagrams. I've put this diagram on the board at the last time, and we said, in order for you to actually work out what happens when I press the start button or I press the stop button, we first need to understand what happens to any circuit in its normal state. And this particular circuit that I have on the screen, in its normal state, we said that this input is off, this input is off, this input is on. It's a normally closed switch, so I will have current flowing through output coil Y003, and as I've represented, motor 2 will therefore be on in the normal state. What happens now when we energize the circuit? Or if I say, what happens if input Y001 is energized by output Y001 is energized by input X001. So I'm going to draw that circuit on the side. Okay, so what happens if the circuit is now energized? All right, you will find that I've now pressed the start button. Okay, that's my live. Current is going to flow there, and Y002 would be energized. I'm going to assume for all practical purpose that it's latched, although it doesn't show it in the circuit. So what would happen now? Remember, in its normal state, this associated switch was associated with Y001, it was open, okay? Now, it's actually going to close, and it's going to become normally closed. This switch, which was associated with Y001, was normally closed, and now that Y001 is open, this becomes a normally open switch, okay? What would happen? I would have current will now flow through this circuit. It'll energize Y002, and current would stop at that point because the normally closed became normally open, and this would now turn off. So motor 1 would now turn on, and motor 2 would turn off. Okay? So you need to understand the transition from a circuit being de-energized or not energized to a circuit being energized, or when I press the start and stop button. And when you are doing this, feel free to actually represent your PLC circuit symbols by electrical circuit symbols. For example, I could initially have done this here, right? When it's de-energized, and then when I'm looking at the circuit, when it is energized, I would do that. Okay? So it went from normally closed to normally open. And I can see here that Y003 would then go from on to off. Okay? So in pencil, don't hesitate. Use your electrical circuit symbols when you are asked to interpret ladder diagrams. As I said, for this particular lesson, I'm going to look at 4 basic diagrams, which is your latching circuit, your basic start-stop circuit, your circuit using a timer, and one of the very important circuits is your interlocking circuit. For those of you who've done your star-delta circuit, which is your start-start, delta-stop, remember you have to have interlocking switches so that when one contactor is on, the other is off. Or when motor A is running, motor B must be off. And also, if motor A is running, I can't start motor B. Those kind of scenarios. All right? For that, you need to know an interlocking circuit, and I'm going to discuss that with you. What I'm actually going to do for this lesson is physically program these 4 circuits into the PLC and actually see how they work. What I'm actually going to do now is discuss each of these 4 circuits individually, starting with the latching circuit that I have in front of me. Okay, what I'm going to do is first draw it on the board. All right, so if I look at a latching circuit, okay, now also remember you've got your inputs as X001 and your outputs as Ys, okay? But for my practical purpose, I'm going to use Is and Qs. So for all my inputs, I'm going to use I, and for all my outputs, I'm going to use Q, all right? This is because I'm using the Siemens PLC here, and I've configured my hardware so that my inputs are I's and my outputs are Q's. So my first switch, which is actually my start button, I'm going to give it an address I0. This is going to be I0.3. Okay, I'm going to use this switch, I0.3, which is my start switch, to switch on the red light that's on my traffic light system. All right, so when I press start, I must switch on the red light. Okay, my address for my red light is Q6.2. Okay, so I'm just going to first just program that line of programming into the PLC and see what happens. Okay, I'm not going to now move here and okay, the program we're actually going to use for the S7300 is the Semantic Manager, and if I go to programming languages, okay, that's my Semantic Manager. I'm going to open it. I'm going to close this one here. I'm going to close this one here. Okay, normally what happens, it opens with whatever you were working with previously on the Semantic Manager, it opens with that. I'm going to start a new program, so I'm going to say File, New Project Wizard. Okay, and now if I say Next, okay, It's going to ask me to choose the CPU, which I already know. It's the CPU 3152DP, but you don't have to worry about that right now. I'm going to go next. This is the important part. Here it asks me for what language I want to program in. Now remember, I discussed STL, LAD, and FBD as statement list ladder and function block diagram. I'm going to call this ladder. All right, I'm going to say next. It's going to ask me for a project name. I'm going to call this Latching Circuit. And I'm going to say finish. Okay, so what it's done, it's actually set up the hardware, etc. for me, okay, because I've been previously using it. You can see it says it's a Somatic 300 station, CPU 312C, etc., etc., etc. I'm not going to worry too much about the hardware configuration right now. If we have time at some later stage, we will discuss that, and I will explain in more detail how you actually change your input and output addresses. For now, I'm going to look at the programming itself. Okay, as I said, I'm not going to get into the hardware configuration right now because besides that not being part of your syllabus, it's going to take a long time to go through the whole thing. So I will discuss a little bit of it later just to give you an idea of addresses. For now, I'm going to look at, for this particular PLC, I have a first block here which I called OB1. And OB1 is actually your main function block. All right, it's called Operation Block 1. What it does, you'll find in your PLC itself, there could be numerous programs, 4 or 5 different programs written by 4 or 5 different people. But OB1 will choose the specific program that you wanted to use at any particular time that you are using the PLC. So if I look at OB1 currently, there is nothing, all right? I'm going to now insert a function. So I'm going to say insert S7 block, and I'm going to call that a function. It says FC1, and I'm going to give it a symbolic name. My symbolic name would be LATCHING. I'm going to call that a latching circuit. And I say OK. If I view details, all right, you can see here next to FC1, it says latching circuit. Now, when I download this program to the PLC, I want it to only use the latching circuit. So as I said, I need to go back to OB1 and tell OB1, when you're running, please only use FC1, which is the latching circuit. So I've now programmed that in there. I can now save that. Okay, I will download that to the PLC. I've now sent it through. Just in case you're not sure that that actually works. Remember, we said this is my interface from my programming terminal or the programming device to the PLC. If I try downloading this again, all right, it says online communication to the adapter is damaged, or it's basically broken. Okay, so now I'm going to reinsert it. Okay, and say OK. And the other thing you'll notice as well, when you're downloading, you'll find this light actually flashing. So I'm going to download it again. All right, you can see it's now taking information to the PLC. So OB1 is done. Let me go back now to FC1. FC1, we said, is my latching circuit. Remember, you also have what we call comment lines. Comment lines are lines that would not be part of your program, but you could use it for putting terms of reference there or putting comments that other people would understand what you are doing. All right, so under comments here, I can, if I want to, write LATCHING latching circuit. All right, and that would now be for somebody else using this program. They will know what it's all about. I'm going to now include my start button, which is normally open. And I'm going to use an output contactor coil. I'm going to call my start button I0.3. And I'm going to call my output coil Q6.2. Now you're obviously asking me, why am I giving it those specific names? In order to save time, what I have done is connected up these lights, all right, to the PLC inputs here. And you can see these 3 black cords are actually coming from those 3 relays. And I've given them those specific addresses so that we don't have to do all of that now, okay? Remember that you would do in your practical lesson in class, and your instructor will explain more on that. So now that I've said I0.3 will turn on Q6.2, let me just first test it. If I press the start button, nothing happens, okay? Simply because the program is still on my computer. I now got to download it to the PLC. So I will say download, and you can see here it's now going to the PLC. And remember I said once it's in the PLC, if I disconnect, the program is still in the PLC. If I now press the start button, okay, you can see the red light comes on, okay? So basically I0.3 is turning on Q6.2, but look at this. If I press the start button, it comes on. If I leave the start button, it goes off. Now, that is not what you want to do. In industry, if you press the start button and you want something to run or stay on, it must continuously stay on. And it is for that purpose that we use a latching circuit. How do we actually latch the circuit? All right? Now, remember I said that your input coil, okay, your input coil, which is your output coil, which is part of your output module, can have as many normally open or normally closed switches attached to it. So all I'm going to do to latch the circuit is put in a normally open switch, and I'm going to give this the same address as my red light, Q6.2. Okay? Now what would happen is when I press my start button, Q6.2 will energize, and when Q6.2 energizes, it will keep itself on. Remember, in your relays, when you do hard wiring, you use on the side of your contactor, you use an auxiliary switch or an auxiliary normally open contact to actually latch the contactor. Here you don't need to do that. You just write a little line of programming, and on condition you use the same address as the address of your output coil, the circuit will now latch. So let's add that to my current circuit and see what happens. Okay? So I'm going to add another line of programming. And remember we said I'm going to call this Q6.2, the same as my output coil. Enter. All right. One important thing you need to understand. If I press this the green light now, what happens? And if I leave it, what do you think should happen? It's going to go off. All right? Why? Okay, simply because the program is still in my computer. I have not downloaded the new steps that I've included to the PLC. So let's do that. Let's download it. Okay, and what you can also do, one nice function about the software is you can actually watch online what is going on by clicking on your glasses. So if I click on the glasses, you can see that I've got a green line up to here, which means there's current flow up to this switch, nothing here so far, and there's current flow up to this switch, nothing so far. What happens now if I press I0.3, which is my start button, and leave it? Okay, you can see the light stays on. It has now latched itself via this normally open switch, okay, which is an auxiliary switch for output Q6.2. And it will now remain latched until I actually switch it off. Unfortunately, I haven't put a stop switch here, all right? So I'm going to have to do that in order to switch that light off, okay? Because you can see, if I press the stop button, nothing happens, okay? The other thing I'm going to do here is, remember I said to you that these are addresses. So although I know it is start, and I know this is the red light, and I know this is the contactor for the red light, somebody else that's reading this program would be lost. So the PLC, the software actually gives you the opportunity to put symbolic names to this. So I'm going to just show you on this one. All right. If I go to options, symbol table, all right, and I'm going to go here, the symbol is I 0. The symbol is actually start, and my address is I 0.3. And then my red light is a symbol, and that we said is Q6.2. If I now save this and close it and go back to my program, it's like magic. Under I0.3, it says start button. Under Q6.2, it says red light. And under the contactor associated with Q6.2, it also says red light. So that's how you would actually add symbolic names to your addresses to make your program more friendly. All right, we're now going to go on to the second circuit. All right, which is your basic start-stop circuit. All right, so if I look at the latching circuit, I've understood that. I now want to look at how do I actually stop this red light. Okay, so I'm just going to take that line off and start-stop circuit. Remember, if you look at it, the circuit says X0.002 is a normally closed input, and above that I've got stop. For my particular program here, my stop button is I0.2. Okay, so all I'm going to do in the same program, I'm going to put a normally closed contactor here, and I'm going to call that I0.2. Okay, and that's going to be my stop button. Now, what I've done for this particular course, normally when you're programming Siemens PLCs, those of you that have Siemens PLC or have worked with it, even your stop button, when you're programming it, you actually program it as a normal open contactor, all right? But to avoid confusion, and for this particular course, I've actually made adjustments on the switch so that it is in keeping with what we are actually learning for this particular course. So for me to now turn off that red light, all right, okay, all I have to do here is insert a normally closed contact, call that I0.2, okay. I remember I also want to include a symbolic name, go to my symbolic table, say stop, and I call that input I0.2, save, okay, minimize. And now if I look at the circuit, once again, just to remind you to continuously do this, if I press the stop button, nothing happens. Why? I have not downloaded the program to the PLC. So download, and you will see it downloading. Okay? Now that it's there, I can switch on my glasses, and you can see it's still showing me that there's power going through my output Q6.2, so my red light is on. If I now press my stop button, okay, the red light goes off, and I've cut power to the contactor. In order for me to start it again, I need to press the start button, okay, then I press the stop button, start, stop, start, stop. And that is a basic start-stop circuit that you would use to start anything. Remember, here I've just got a red light connected to a relay, which is connected to the output module of my PLC. Remember, the output module is 24 volts, so this is a 24-volt relay. However, the red light is 230 volts, so I'm using that relay to actually switch 230 volts to that red light so it turns on. I think in electrical you've discussed relays, so I'm not going to get into that now. I hope you understand how the start-stop circuit works. All right, I'm now going to add to the circuit, and the next circuit that we are going to discuss, all right, is a circuit using a timer. Now, what I want to do, okay, so all I'm going to do is adapt the circuit to the one I have here. I'm going to say, all right, I'm going to start this light, okay, and if I want to stop it, I'll press the stop button. However, I actually want this light to stop after 5 seconds, all right? So I'm going to need to put in a timer. All right, the way I do that is if I extend this, okay, I'm going to call that T1. In Siemens terminology, we can use T1 for timers. In some other programs, you may have to write the word timer, etc. But for the programming, in this case, I just need to write T1. But I'm going to write a symbolic name here, timer. And I said, I want the red light to switch off after 10 seconds, or let's make it 5 seconds. Or I'm going to call it switch off after 5 seconds, timer 5 seconds. All right, what type of timer? Now remember, we discussed on delay and off delay. I want this timer to switch off after 5 seconds, so it's going to be an on delay timer. Okay, meaning the timer will delay or switch or energize after a delay of 5 seconds. When do I want this timer to start timing 5 seconds? Obviously, the moment I press the start button. So once I press the start button, it must start timing 5 seconds, and after 5 seconds, it must actually switch the red light off. How do I know that the red light is on? Okay, when I press the start button, we said Q6.2 is actually energized. It latches itself, so it's on. And from that point, I want the timer to start timing. So remember, I said I can have as many normally open, normally closed switches attached to that coil as I want. So I'm going to call this as well Q6.2. All right, and you can see the red light is going to turn the timer on. After 5 seconds, it must turn the red light off. If I download this, okay, stop button, start button, I can watch the timing. You can see it times down from 5. It reached 0 seconds and nothing happened, okay? Reason being, yes, I asked 6.2 to start the timer, but I have not asked 6.2 to switch off the timer. How do we do that? Okay, what I'm going to do is I'm going to stop there, and I'm going to leave you to think about it. So when I see you at the next time, we're going to take off from this point and look at how this timer actually switches off Q6.2. Thank you once again for watching. And for now, please, people, stay safe, stay at home, and look after your loved ones. Thank you.